Hi everyone, I'm Doa Chowdhury. I'm a PhD candidate at Karma and the co-instructor of this workshop. I'm very excited to welcome you all and hope that you'll enjoy this workshop this summer with me and Lloyd. Because of the pandemic this year, we selected an Arduino-based electronics kit that includes a big variety of sensors and electronics. And in this video, I'll introduce you to this kit and your alternatives as well and help you set it up. So the main reason why we use this kit is that because we had to host this workshop remotely and we weren't able to distribute a custom made kit for you. We selected this one and it's useful because it includes a big variety of items, electronic sensors and other components that you would already need. But I would just want to remind you that you're not limited to the kit and you can use other alternatives, other controllers, and you can expand if you're using this kit still you can expand by adding other sensors, and we should talk about it if you're interested in that. So what I normally use when I design musical instruments, I use the Tinsy controller. The Tinsy series come with different types of controllers where you can couple it with an audio shield and do more embedded audio systems, or you can select a different version, have like more analog pins depending on your project. If you're doing more embedded audio focused work, you might prefer a Bella board or an out board. I sometimes also use ESP32 and its feather accessories, which helps you. It has an audio module and helps you connect it easily with Bluetooth or Wi-Fi. Arduino is still very frequently used, so what also we're going to use is a Arduino Uno based controller. It is a very similar setting with the power inputs and outputs, analog inputs, digital inputs, and outputs, sometimes PWM outputs, works as a digital as well, or digital works as a PWM. We have the communication ports for I2C and I2S. If you need to use a specific sensor, you might need to set up those pins, and we can talk about it more depending on your project. Your sensor selection might change. But in this kit, what you should have is, of course, the controller board, a prototyping board, passive elements like resistors, diodes, LEDs, capacitors, or potentiometers. Or you can also use very frequently buttons, a slider, or like the joystick controller button. You might have, you're going to have, and you might need jumper cables, LED screens, and specific sensors like proximity sensors. So this is kind of the list, of like a visual list of equipments. But if you want to access the actual list, components, and also I don't have a CD player. You might also not have a CD player, but the kit comes with a CD. What the CD has also available on the website, the tutorial PDFs and the sample codes. So I'll quickly stop my presentation and go to this website, a Lego website. And if you go to the resources page, there's a download link to download all of these equipments, and you can access the component list as well. So here we are. If you go to the main web page for the controller, you have the kits, and you need to select from the STEM kits. You need to select the white one, Uno R3. In this web page, you have the kit, some introduction video, which is not necessarily important for you right now. But if you scroll down, you should be able to access the component list, and you can compare what you have in your kit, if you have everything. If you click the resources page, there's a download link, and if you click this, it will show you the zip file, and you should be able to access there. Once you downloaded the zip file, You can unzip it and you'll have a selection of languages. And so if you select the language that you prefer, you'll have three parts. The first part will help you with the preparation, and also have the list and how to download and how to set up. So if you have trouble, please refer there. It's a very simple instruction there as well. So how do we set up and connect the Arduino IDE? So first you want to do is, if you don't have it, you want to download the Arduino's interface. To do that, you can just directly go to the Arduino's website and select the software and download whichever is suitable for you. I would download the Mac version, Mac OS 6. So once you complete that, you can also find a tutorial on setting up and the preparation part. Either for Mac, if you're a Windows user, you might need to follow a different tutorial for Windows setting. Once you have your Arduino IDE running, we'll just compile and upload a very simple test code. So start by connecting your board to the USB port of the laptop, of your computers, and open the Arduino IDE. There are two important settings that you want to do before you start coding and trying to uploading your code. The first one is selecting the right board. The board should be Arduino Uno board under Arduino board. And the second one, selecting the right serial port. And it should be the USB port, or it can appear as a serial port, or sometimes just COM, C-O-M. In mine, in parentheses, it says Arduino Uno, so I know that this is the correct one. So if we quickly go to the Arduino, when you open it, you will first see just a sketch for you to complete. So this is how you code an Arduino interface. You have a sketch page. You can save this one in your folders, and then you put your code under the loop. So what we're going to do is actually today just run the test code and set it up. So to set up, you go to Tools. Under Board, you need to find Arduino boards and select Arduino Uno. Once you've done that, you need to also select the port. Under Serial Port, I have the USB modem Arduino Uno port, and I select this one. And once you select both of these settings, you're good to go. Now you can find an example code under File, Examples, Basics, and click Blink. And this will open up the Blink code. What it does is very simple, just turns on the built-in, first setup, initializes the digital pin, and then turns on and off the built-in LED. So first you select by compiling the sketch. Sketch compiles properly. It'll give you a success page. If there's an error, it'll show you under this console. The sketch done compiling was successful. Now I know that the code is working, so I can just upload it to my board. And now code is done uploading successfully. What you need to see in this part is your code, if it's done uploaded correctly, should blink. You should be seeing your LED blinking on and off. So what I want you to do, just make sure that you have all the components in your kit, your controller is working, and pick an introductory project in the module 2, and just run the example code and make sure that it is easy to set up and everything in your kit that you want to use is working properly.